Good afternoon to you all. This is Guy Crets from IHC. Welcome to this webinar about choosing between Kafka, Pulsar, and other messaging technologies. Actually, the trigger for this webinar was a session by, or an article actually by someone from TIBCO, Bill McLane. TIBCO also being a business partner of ours, about these different messaging technologies, and that led to getting therefore we went a bit deeper, and I said, yeah, nice idea to have a more detailed talk. So nice to have Bill McLane, the author of the article himself, here in the session. The article which led to this session is available as an attachment, as well as the presentation or the slide deck that Bill will present. For the organization of this session, again, the slides are already available as well as the article. You can download and follow along. We will have a 30-minute presentation by Bill, followed by 15 minutes open Q&A. The questions are to be asked via the public chat, and then they will be discussed by Bill and optionally myself. And then after about 45 minutes, we will close the session. If you wish, you can stay online and have some further discussion after we finished the official part. So don't run away if you're interested. We will again also share the presentation afterwards as a recorded video that will be distributed automatically. Okay, these are the main points, I think. First of all, welcome, Bill. I think you can introduce yourself better than I can. So, all right, go on.
My name is Bill McLane. I am the product evangelist at TIBCO Software, and I have basically been working in the messaging communication business line with TIBCO and outside of TIBCO and with customers for over the last about 20 years. Really focusing on how digital communications can be leveraged to provide services like integration services, building event-driven architectures, service-oriented architectures. We call them all these different names over time, but we ultimately have a very similar problem and challenge, which is foundationed in communications. And so today we're going to kind of bring together some of the discussions that we've had really over the last 20 years and talk a little bit about the history of messaging, talk a little bit about what we are doing to bring together some of the newer messaging technologies and how those can be leveraged appropriately in an ecosystem where you have a lot of choice. So I think, since we've kind of gone down this path, I will go ahead and get started, and hopefully Guy can jump in here towards the end, and we can have some discussions around what we're looking at with some questions. There he is.
So again, for the practical side of things, the actual trigger for this presentation or this afternoon session was a nice article by Bill, which really triggered me and then led to this to the organization of this session. On the practical side, we will have a 30-minute presentation by Bill, so thanks already for starting that. You can ask questions via the chat, which we will then take along. And all the material, both the article and the presentation that Bill will be presenting, is already available for download. At the end, all participants will receive a copy of the video, and it will be also made publicly available to everyone. After the session, we have 15 minutes Q&A, after which we will close officially the session. But feel free to stay for a more informal chat with Bill and myself optionally, so we can go along. We have our agendas blocked, so we can discuss your particular or specific question. Again, ask via the chat. And okay, that's it for now on the practical side. So Bill, back to you. Let's go ahead.
So let me go ahead and jump over here, and I'll start sharing. So as Guy said, the real key that I think, I'd really like to kind of focus this discussion on is that, with messaging, there's a lot of questions that come up that are focused on what should I use to meet my business demands. And for many, many years, we focused on this concept of, trying to find this one thing that fit all of our solutions. There was this whole movement to normalize what messaging software was being used within an organization. And what we found out of that is that that's a very challenging thing to do. But before we begin, I think we really need to focus on what messaging truly is. And the best way I'd like to kind of discuss this is, I think this last year that we've all lived through in many different ways shows the importance of what we have to have with regards to communications. With the COVID-19 outbreak and how every single one of our lives was changed dramatically in the way we worked, in the way we communicated with our friends and family, it truly opened up how important communication is with regards to our everyday lives. And that communication framework, the ability to connect, the ability to interact, the ability to make decisions, all was foundationed in the fact that we needed a way to exchange information between different pieces of our lives seamlessly. And it became so much more evident when the channels that we were used to were gone. When our daily lives, where we would go into the office and have that general conversation with a group of engineers on a problem we were trying to solve around a whiteboard, that no longer existed. So how do we facilitate those types of communications? And those same types of communications challenges exist in the digital world between software components and hardware components. We're always struggling to find a way to normalize the ability to have these components communicate together, whether or not they're things that we're trying to integrate for integration between different software application packages, whether there are different solutions that we're trying to scale to meet new demands, or if we're trying to just leverage the technologies that we have. Communications is at the core of all of that. And the biggest challenge that we face is that while on the surface it seems very easy to communicate, it really isn't. There's so many different pieces to how we communicate that have lasting impacts. And so at the foundation, that's what messaging provides, is the ability to normalize all of these different communications techniques, these different communications approaches, and leverage them across all of the different software and hardware components. Now, one of the things you're going to hear a lot is this concept that messaging is this new concept, or more importantly, the new terminology around messaging. We now have terms like stream processing. We now have terms like event-driven architecture. We had service-oriented architecture. We have all of these different terms, but they all are foundationed in a concept that goes way back, even before the true concept of messaging existed, to when we were building out logical networks within ARPANET and things like that. There's always been a requirement to bring disparate systems together and to have them communicate at scale, at speed, and provide the reach to multiple different nodes within an organization and beyond an organization to multiple different regions and now across the world. So messaging is not, iMessage or LinkedIn or texting, but all of those components use an underlying foundation of what we call messaging to service the distribution of that data. So the real question becomes, why should we even use messaging? As an engineer, one of the easiest things to do is to say, I can build a connectivity piece between my application and it will seamlessly work. It will work to a very large scale. I could write a socket layer that will allow me to basically distribute data between one component and another, or one component and multiple components. And that is true. As long as we have a system that allows us to speak the same language, as long as we have a communications infrastructure that allows us to communicate in the same way, we have no problems. The challenge comes in is when we speak different languages. And as many of my colleagues know, I get the opportunity to travel all over the world, at least I used to. And one of the skills that I have been blessed with is, the ability to communicate. Unfortunately, I can't communicate well in any other language other than English. My French is horrible. Most of the other foreign languages, I've been to Korea and many other places. Foreign languages are not a skill set that I have. So communicating in countries that don't speak my native language becomes very challenging. So again, it just emphasizes the need to be able to communicate across multiple different regions, being able to communicate in multiple different ways. The other important reason to use messaging is that we always have different aspects where communication can become very complicated. It's one of those scenarios where you don't really think about all of the different aspects of communication until you really start to look at the differing approaches. But a great example of that is today we're speaking on a webinar where I can talk to my computer and I can reach many people, and that's great because I can have a microphone, I can have my interface that allows me to scale that very seamlessly. But long ago, in days gone by, we used to have these types of things in person, and we used to have rooms where we would have hundreds of people or thousands of people that would be sitting listening to these different types of presentations. And the question really comes down to is in those types of environments, if I need to communicate to a large room of people, I need to know if everybody can hear. I need to know if everybody can understand the message I'm speaking. Is everybody getting the same message? Am I speaking too fast or too slow for a given group? One of the most interesting communications challenges I faced was when one day I was over in Japan giving a presentation, and I was very cognizant of the fact that I was being translated in real time. And one of the things that was very apparent was that if I spoke fast, there was a very significant challenge in the translator's ability to speak to the people who wanted to hear it in their native language, in Japanese. So to make sure everybody understood that message, I needed to slow down my speech pattern. I needed to take pauses to allow for the translator to catch up a little bit. And that was really the key to understanding that environment. That's what messaging really is designed to do. It's designed to simplify how we communicate at an application and at a digital level. It provides the framework for scaling that communication from one-to-one to one-to-many or to many-to-many. And it lies at the foundation of all of these different processes that our enterprises and organizations need to apply, whether it's building out an IoT network for data and sensor information, or it's doing things like transaction processing or financial services market data distribution, or it's looking at building real-time applications that need to do inline stream processing. They all have the foundation that we need to communicate. And that's really what messaging is designed to do. It's designed to provide that connectivity to allow for applications to use any of the patterns that are available, and to do so in a framework that allows you to deploy that information anywhere and anytime. But as I said earlier, one of the challenges that we faced, I think, over the last 10, 15 years is this concept to try and normalize the process of normalization, which is messaging. We've moved to this approach where we are trying to find that one solution that meets all of our demands. And what we've learned from that is that some of the best lessons we've learned are from our childhood. And that really centers on this one toy that I remember vividly playing with as a child. The fact that I remember playing with it tells me I probably was playing with it a little bit too long, because these are designed for infants to really understand the concepts of shapes and spatial orientation. And what we learned from this toy is that it's very easy to do things in a way that they're designed to do. But if you try to take that square peg and fit it into the round hole, you're never going to be successful. You're always going to have a solution where you're trying to force something into a model that just doesn't work. And that's one of the key things that this toy taught us as children. It was that there are many options that are available to you. And sometimes as a child, having that many options became frustrating because you couldn't find the right shape to fit into the right hole. We also learned very early on that trying to force that square peg into the round hole would never work. And any of us parents who have seen our children get frustrated know the end result of that, which is there's usually tears, there's usually a temper tantrum. It becomes very frustrating. And as a parent, it's very difficult to watch that because we see that the solution for them is sitting right in front of them. As hard as they're trying to fit that square peg into that round hole, if they just would turn the toy and find the right hole to put that square peg into, they would be happy and satisfied. But a lot of times what happens is that children will force the wrong solution. They'll try to fit that square peg into multiple different holes, and then they get frustrated and the toy gets broken. And that's really where I think we've gotten with some of this communications infrastructure. By no fault of the industry itself, we have so many different unique options for providing communications that it's becoming frustrating because we have so many solutions that sit in front of us. And how do we choose the right solution for our digital communications framework? This is just a small sampling of some of the different options that are available, whether it's Apache Pulsar. If you're Amazon focused, you could see SNS and SQNS. You have multiple different solutions in the open source world with Kafka, Pulsar, RabbitMQ, AMQP. You have multiple different standards that are available that are out there. JMS for Java Message Service, MQTT for IoT. Where do I basically land when it comes to what I need to do? And that doesn't even go into some of the proprietary solutions like TIBCO FTL and some of the solutions from IBM, MQ, and all of these other solutions that are available. So how do we decide what's the right solution to meet our business demands? And I think the key here is that we have to reevaluate how we approach communications. We have to reevaluate what we're doing with the communications and not build solutions based on the communications infrastructure, but build the communications infrastructure to service the needs of the business and the enterprise. And that's really where we have to start, is we really need to look at what are the requirements that each individual and unique application has, whether it's building for real time or high throughput or low latency. A great example of how we can look at this is, the financial service industry has been doing this for quite a long time. Right? Market data distribution is probably one of the highest demand, highest throughput, lowest latency solutions on the market. When you look at the amount of trading that's happening within the financial services market, like the Chicago Mercantile Exchange or the Australian Stock Exchange or the London Stock Exchange, the amount of data distribution that has to occur is phenomenal. And that data distribution has unique requirements compared to the transactionality that's needed for clearing data for orders and bids on the buy side. So you need the ability to service both. And can one solution meet those same demands, given that they're on almost opposite ends of the spectrum? Low latency, high throughput data in market data distribution is something that I'm not concerned about if I lose data, because I'll get more data from the same tick a few seconds later. Whereas an order processing engine that's transactional, I definitely want to make sure that every single operation that's executed is guaranteed, because if I missed a buy or a sell, then I have a real problem. So what are the requirements that an individual application has? Is it transactional or persistent? Does it require us to go across multiple sites or multiple geographic zones? What are the different ways that we need to acknowledge and interact with the messaging system? How do we do that? And what are those requirements from, not from the messaging layer, but from the application layer? The other thing that really comes into play now, more so than 15, 20 years ago, is what is the application? What are you trying to do with regards to the data that's being serviced? Long ago, it was a very simple question, because messaging and communications and applications all ran within our own data centers. But now with cloud, we have a whole nother layer that comes into play with regards to how we're applying messaging into our application space. Are you trying to build something that provides integration services across multiple different applications? Are you building an application that's looking to do stream processing, where I'm actually ingesting data, manipulating that data, and then reprocessing that data for other applications to consume? Are we building microservices or an IoT infrastructure where we're connecting sensors? Or more importantly, the newest one in kind of the realm of terminology, which really isn't new, we've been doing it for a long time, is building event-driven architectures, using information within our organization to trigger events and leverage those events to trigger other events so that we can make real-time decisions. All of these types of applications have differing requirements, and because of that, we need to have a solution that comes together and meets those demands, not a holistic approach where we have one size fits all, but it's very focused on a best of breed approach to how we meet those demands. So back to the same question: what solution fits best for my application? And the key that I think we have to understand is that one size doesn't fit all. We've learned from the past experience that trying to build a monolithic common framework for communications just doesn't work, because we're trying to force that square peg into a round hole. It will eventually go, but we sacrifice so much to try and meet the demands of all the different types of application patterns that we lose all of the benefits that a given solution is designed for. And so we need to architect an approach that allows for applications to make choices based on the requirements, and then more importantly, seamlessly integrate those communications patterns so that they don't have to make sacrifices on what they're using to communicate effectively between their individual application nodes, and then more importantly, how they can integrate with solutions outside of what their application was originally designed to do. Now, in the open source world, we've seen this approach as well, trying to find this messaging nirvana. If you go and look at just some of the solutions that are out there, Pulsar, Kafka, AMQP, JMS even, which is not necessarily open source, but is open specification, they all have been striving to meet this common demand of trying to meet all the demands for a given usage pattern. And what we really have found is that doesn't work. And so that's why at TIBCO, what we take is an approach to say, we're going to offer a messaging solution that allows you to choose based on your requirements, not based on an individual product. So within our TIBCO messaging offering, we offer all 6 of these components. And I will say, these are the 6 that we offer today. What we offer in the future, is yet to be determined, but I can tell you that I know there will be more offerings that are coming into this solution, because there are more communication patterns that are becoming prevalent. And for different application spaces, those patterns make perfect sense to allow for them to be an integrated solution with a common framework that allows you to choose the appropriate communication pattern and integrate them at the messaging level so that they seamlessly can bridge between each component without having to make sacrifices. Now, about 3-4 years ago, we introduced open source to our offering. And we did so because we saw a very clear pattern that open source messaging was really starting to mature to a point where we had enterprise quality solutions available and being leveraged for production systems, and we wanted to support those. It started with Eclipse Mosquito to support MQTT for IoT and Apache Kafka to provide the support for stream processing and the ability to leverage distributed inline communications for streaming applications. But we also then added Apache Pulsar, which provides a very significant high-performance infrastructure that kind of melds the mentalities of a fully distributed client-based Apache Kafka approach and takes some of the benefits of a server-based architecture and brings those stream processing engines and processes into a more centralized model. And that's really why we added those. But there is a big debate going on right now in the open source community on which to use. Why is there Apache Pulsar and Apache Kafka? And I'm not here to say one is better than the other. What I am here to say, though, is that they each have very unique benefits depending, again, on the application that you're looking to build and the process you're trying to build. Kafka is built and designed for streaming data pipelines and building client applications that are natively built to code and build out stream processing as part of the application. Pulsar, on the other hand, has moved all of those components into a more centralized model and has really been built for that enterprise global distribution where I need multiple different applications accessing data across multiple different platforms, where I need segmentation of those applications and I need to replicate them across multiple geographic zones or globally. And I can do so allowing for low latency and high throughput data distribution. The other thing that Apache Pulsar really brings to the table is this concept of rolling the stream processing into a server or broker-based model, where I can deploy my stream processing engines as a part of the broker and allow for inline stream processing of data and having the broker be the interface for ingesting data, processing that data, and then republishing that data for client consumption and doing that processing in line. So the statement of truth is that both Kafka and Pulsar have their strengths and weaknesses. Kafka has been widely deployed and has a very, very large developer community in the open source world. We fully support Kafka, and it has been built and designed for distributed long-term data retention. Pulsar, again, is been built around this enterprise community where you are trying to bring all of that data into more of a centralized pattern and allow for a wider scale reach of that data. And so each of them have different aspects to why they're of value. And Kafka and Pulsar now have become really key to an open source solution. And with the adoption of Kafka on Pulsar, you can actually now provide native migration between Kafka applications that are written completely to use the Kafka API. You can point them at a Pulsar broker and they will seamlessly work because now Pulsar supports Kafka as a protocol. And so as we wrap up, one of the things I do like to kind of highlight is just a use case that we have from one of our partners down in Australia. The Australian Stock Exchange was doing what I said earlier in the financial services side. They were doing transactional processing and clearing of data with our proprietary based JMS solution called EMS. They leveraged some of our appliances to do all of that work. And then over time, they've started to build integration solutions and analytics platforms on that. And most recently, they've really started to look at adopting Kafka for a large number of their stream processing engines. And they needed a way to bring all of that together. And that's where TIBCO stepped in to help them build the solution that allowed them to take their existing EMS infrastructure, and with TIBCO messaging and its native support for bridging between EMS and Kafka and Pulsar and all the other components, they were able to seamlessly deploy Kafka-based applications and leverage the existing technology they had and build new technologies on open source solutions without sacrificing any of the infrastructure that they already had in place. They didn't have to rip and replace. They didn't have to basically black flag and upgrade all of the applications. They could provide a seamless rollout and do so by providing a 30% decrease in customer impact on given incidents. So that's where I'd like to kind of wrap up, which is that messaging is at the foundation of that digital transformation. So whether you're looking to build integration or stream processing, if you're taking the foray into event-driven architectures, or you're building SOA or microservices, the key is that messaging is at that foundation. If you have a solid framework for communications, you now have a nervous system that allows you to build a solution that can be seamlessly scaled, it can be seamlessly integrated, it can be seamlessly deployed, and that those solutions should be chosen based on what the application requires. And then when those solutions need to be tied together, messaging can be augmented and integrated directly to allow for that framework to provide the best of breed communications for your applications. So with that, I'd like to say thank you, and I think we're now actually just about time to go into some Q&A. So I will stop sharing my screen here, and we will come back and see what types of questions we have.
Yeah, thanks. And thanks, first of all, Bill. Very nice. Nice within time, so well done. And again, it's also a question that Pulsar have also been looking at it in quite some detail. It's interesting evolution, how the world still keeps evolving in this world of messaging, and we are not at a standstill, but people keep reinventing. So I got a first question that came in, and that's about the HTTP protocol. And the question actually boils down, is that will it conquer the world and will it push every other protocol aside? And so will there be only HTTP in all these versions, or will there remain room for something else, something like Kafka, Pulsar protocol, and so on?
That's a great question. What I would say is I think HTTP as a protocol, REST-based services and things like that, they're here to stay. I mean, the reality, right, is that interface is something that is going to become more prevalent. And the reason I say that is that what you're seeing is, I would argue, a shift in what skill sets are needed and required for your typical business operations person. Remember, when I was in school, I went to school and got a degree in computer science, and I learned how to program in C. I learned assembler, but nobody else at university was taking computer science courses or things on how to interact with computer systems and digital systems. Now, my kids, my daughter that's a freshman in high school, my son who's in middle school, are taking basic programming courses, not because they are going into that field, but because every field has some aspect of programming that's being built. Marketing, for example, is a huge layer of programming that's being built using RESTful services to gather data and use that data. So I think that HTTP is going to become just another form of communications. Now, is HTTP going to be the primary interface for that enterprise-grade quality communications? Absolutely not. There are so many limitations to the HTTP protocol that it doesn't make sense for the core infrastructure. But it does make sense for that client interface to allow access to data. And again, it actually shows that demand for being able to be flexible in how we interact, right? Look at all the APIs we have. We have REST, we have Go, we have Java, we have C, we have Pi-based applications. I mean, there's the number of interfaces is endless, and those are going to continue to grow, I think.
Okay. And again, I see already a number of questions come in, so that's very nice. So keep shooting them. A second question I got is on the Kafka protocol. Actually, the question is it open source?
This is a very interesting conversation. So Kafka, yes, Kafka itself, the core Kafka is completely open source. So that's one of the reasons why Pulsar was able to go off and say, we can build a Pulsar-based Kafka protocol where the Pulsar broker can ingest Kafka data and use it as the protocol and transform that into its backend solution. So yes, the Kafka protocol is completely open source.
And that's also the foundation that you use for building those bridges.
100%. So yeah, connect. What's interesting is in the Kafka community, there's a number of things that are open source and available as part of the core. So K-tables, connect, the APIs, the pub sub APIs, the Kafka core. But then there's a number of things that have been built around the edges of Kafka that are either labeled as open source but not open license, or are proprietary-based solutions. And so, a great example of that is one of the things that a lot of people leverage is KSQL. And KSQL is actually not a open source, open license protocol. It's a proprietary protocol. And so if you really want to do things in an open source way, you can use K-tables and there are other SQL engines, but KSQL itself is not. And so that's where you got to kind of get where open source and open protocols come into play. But the core Kafka and the core Pulsar are 100% open source.
Yeah, I got a related question here that is on the ecosystem. So the question there is, am I correct to assume that the ecosystem for Kafka is a big plus in comparison to Pulsar? So the fact that there is more adoption right now of a Kafka in comparison of Pulsar, and is that a plus? And maybe how will it evolve?
I think that the ecosystem of Kafka is a plus for Kafka. One of the things that you see is that Kafka's been around and in the ecosystem, in the market a little bit longer. And so therefore there is a lot more variety that's out there right now. That being said, Pulsar's ecosystem has been growing rapidly. Pulsar's contributor base is upwards of, I think they're now at 25 unique companies, whereas actually Kafka's contributors are actually fairly limited. It's more of it's a smaller contingent of control. So there's benefits to both sides of that, right? That have value, but Kafka definitely has, I would argue, a history of wider adoption and a larger community. But that value proposition for Kafka is slowly starting to diminish because Pulsar's community is growing.
Okay. Maybe again, a lot of questions about Kafka versus Pulsar, of course. And then the question there is, how does Pulsar relate to Kafka in terms of complexity? And that also in context of a medium-sized company. My assumption is that Pulsar is the easier one, but is that right?
The way I would classify it is that they both have unique complexity issues. And I would argue every messaging solution, as I said, communication isn't easy. There is always complexity in how you build your solution. Kafka is very distributed in nature, and now actually with the adoption of removal of Zookeeper in Kafka, that can, and I will preface can, simplify your architecture with Kafka, but it also means now that Kafka nodes are doing more. And so Pulsar and Kafka, I would argue, are similar in the complexity that's involved. They are very distributed in nature, which distributed systems take a little bit more thought process up front. They all have multiple different components, especially as you start to grow. It's very easy to get a Pulsar broker stood up as a standalone broker. It's very easy to get a single Kafka node stood up as a single node. It's when you start to look at functionality beyond that, where I want to do multiple node replication or geo replication across multiple zones. That's where the complexity comes in, and they both have challenges there. Pulsar uses Bookkeeper and has native functionality built in for geo-replication. So Bookkeeper, Zookeeper, and the broker nodes will do that replication. Kafka, you have to look at taking a node structure and using something like MirrorMaker 2 and deploying MirrorMaker 2, and how do I do that effectively to meet my demands? So they have similar natures.
Okay. Because related to that is another question, and that's on your observation that Kafka is lacking disaster recovery. Why the observation on Kafka lacking disaster recovery? It enables replication recovery, like minimum in-sync replicate support, replicas support, and so on. So, is there an opinion on that disaster recovery part of Kafka?
In Kafka is possible, and it really depends on, again, looking at the perspective of that you're looking at. With MirrorMaker 1, if you're looking at a true open source approach, MirrorMaker 1 was significantly lacking in disaster recovery abilities. So there was a lot of holes that were involved with MirrorMaker 1. MirrorMaker 2 actually is now a great solution to provide you with the ability to do disaster recovery and do data replication between multiple different zones or multiple different data centers. The other solution that's out there that a lot of people tout is something like Confluent Replicator. And the statement is, yeah, that's great, but that's a proprietary piece of software that's being run. And MirrorMaker 2 actually, I think, meets most of the demands for disaster recovery now. So yeah, 100% that you have the ability to do disaster recovery in Kafka. The biggest difference is that their disaster recovery in Kafka versus Pulsar is Pulsar's built it into the broker ecosystem, and it's part of the core concept of what it does. Whereas Kafka is looking at replication of different clusters, and it's outside of the core piece, right? So you have to build those differently. You have to approach them differently. Tuning Kafka replication, especially for high performance solutions, can become very challenging. And the same can be said for Pulsar too, but Pulsar has that natively built in. So that's where those two are different, is that Kafka's approach is very much that distributed architecture, where if I need to do something, I can bolt on components to do that, whether it's a connector, whether it's a replication, whether it's those pieces, where Pulsar is taking some of that into a more centralized approach.
Indeed. And then maybe this is the last question we got. So, and that's all again very nice. We'll be 45 minutes. So we'll be wrapping up at 45. The final question is that I see here is on the on packaged applications. So packaged applications or SaaS applications typically have their own specific ways of integrating and exposing themselves via standard APIs, but many other mechanisms. But will there be a time when they will adopt messaging as a standard built-in connectivity option? What's your expectation there? We don't hear you, Bill. We don't hear you.
Yeah, package application.
It's a nice question.
Yeah. I wish there would be a state where everybody would adopt a packaged approach to messaging, but I think the reality of that is that it's always a cost versus reward initiative, right? Many package applications are not necessarily looking at how do we integrate with other solutions, how do we tie these things together. And so that's why a lot of them don't take that approach. Where a great example is at TIBCO, one of the things we try to do very heavily is when we talk about our messaging components list, when we build a packaged application, whether it's for integration or stream processing or analytics, we don't want to have to force people into a specific solution. So we try to support all of those solutions. Some of our historical products that existed before these solutions are provided, we provide the ability to bridge into, but new solutions now have the ability to leverage Pulsar, Kafka, MQTT, all of them. So there's definitely, I think, a point where I wish every package application would take that approach, but that goes back to the old, nirvana state where until we have a common framework, which has been proven not to work, we're never going to get there. AMQP was a valiant attempt to try to put a protocol on the wire that says, hey, everybody just use this protocol. And it's used in the Red Hat Linux arena. It's used in a couple of open source solutions, but it's not a real viable solution for large scale enterprise-based deployments.
Yeah, indeed. I suggest, in the meantime, many more questions came in. So if you can stay online, Bill, and then we will continue. But what I suggest now is that officially that we close the official part. And I want to thank, first of you, Bill, for you really triggered me that couple of months ago that we, before we got in touch with your article on this subject. It's available as part of this session. Of course, I want to promote a bit our activities around messaging that we share on the TIBCO offering. And we as IAT, as a business partner that we provide here, especially in the Benelux market. So if anyone participating wants to reach out to us, feel free, of course, to get not only the product and the messaging implementation, but also the product support and the services around it. So short part for the commercial side of things, of course, we need to make a living as well, and also want to serve our customers with good, well-supported technology. So that will be the official part. I also want to thank all the participants, but I suggest that we stay online and tackle a few more interesting questions, if that's okay with you, Bill. So I suggest that we continue until 5 Belgian time. Yeah. So again, who wants to leave, feel free. This is the official ending, but we will continue with a few more questions, and then. And of course, I see here on the schema part, we already discussed that as well. So the fact that indeed, and also the question here is about messaging schemas. So does that influence the choice of product?
I think it does. I think it does, but what's interesting is schema repos. Yet again, it's interesting because with messaging, there's a lot of new approaches, but in reality, a lot of this isn't really new, right? The whole concept of a schema repo is this centralized model where metadata around a message structure can be maintained, looked up, modified, and managed. And it's funny because messaging solutions, I'm going to go all the way back to TIBCO's foray into something like TIBCO Rendezvous. They all had schemas. They all have this concept of a message structure. It's just that was a self-describing message where we would basically create the message structure, and the message was encapsulated in the structure that was put on the wire. And then somewhere along the line, which TIBCO did too, so we said, why are we sending all this extra data around when we can actually create essentially like a data dictionary that holds all of the information about what these different structures are, what the formats are. So within our proprietary high performance solution, TIBCO FTL, we have a Realm server that has all of the formats built in, and it's a schema repo. You go in and create your solutions. Pulsar, Kafka, they all have the concept of having an external repository of the metadata, as well as the concept of providing a self-describing message. So, Kafka and Pulsar, you can send JSON-based structures that are fully self-described. So it's all a function of that. And yeah, I mean, I think schema repositories for communications are somewhat common now. I think the expectation is that you want and need the ability to do both self-describing types of structures, but also want the ability to define structures that are available. I mean, look at what we did with SOAP and JMS. I mean, that's the same conceptual idea, just at an application space.
Yeah. And also with the adoption, like for instance, or the coming of Avro as a message format, also the switch to binary formats, of course, which introduces a requirement for message definitions in there. Yeah.
Yep.
Yeah, there's also a more critical question on the mixture of multiple messaging solutions in a single landscape. And so, how far do we go, of course, with that?
Yeah, I mean, it's it's interesting because I think that's one of the challenges that you have, right? Is that you have to look at the landscape that you have. Um, I would argue we have this pendulum that swings back and forth at times, where there's a point where the ecosystem is one way where we have a common center of excellence that's building these solutions, and then there's an ecosystem that swings the other way. The pendulum swings. I think it is a balance that you have to play, right? Because you could very easily start adopting multiple different solutions. I mean, I would actually argue that I think Kafka's adoption into many enterprises was adopted because developers were looking to build point solutions, and Kafka was the easiest, most accessible thing to them, and it worked. So why not use it, and why not leverage that when I'm looking to build an application? And I think the key question then becomes is how do you, like you said, how do you manage that from an enterprise perspective? And I don't have an easy answer to say,
No.
one is too few and five is too many, but I think that again that there are a number of applications that are very specific, right? If I'm building an IoT based application, I need to be looking at an IoT based protocol like MQTT to leverage for those types of applications. But if I'm building an IoT solution that's feeding into an enterprise event driven architecture, I need to look at how do I take that MQTT protocol and use it beyond into something more transactional. We work with a pharmaceutical company that's doing, all their labs and manufacturing warehouses are outfitted with sensors, and they're using MQTT types of data.
Yeah.
But that's not appropriate for the back end analytics engine that's looking at how they're operating. So they need both.
Yeah. Personally, I still like the EMS part, the JMS part. Personally, that's my background, and actually, it's still working fine. So don't throw it away. I would say.
Well, I mean, the reality too is again, sometimes we adopt new solutions because they're there, not because they have necessarily any real value. I think to your point, right? JMS, EMS is widely deployed across all of our customers, and it's continuing to grow because it's a solid, proven solution. Rendezvous, as I mentioned earlier, which was developed right around 1986, we still have large numbers of companies that are running Rendezvous, and a lot of the manufacturing of the silicon on all of your computers is still being driven with the usage of Rendezvous.
Yeah, and a peer-to-peer model.
They are peer-to-peer, and it's still, peer-to-peer is still a very viable solution for many types of applications. Again, another piece in the puzzle is what is the goal of your application?
Yep. There's also a question on the latency of Kafka versus Pulsar. Is there any numbers on Pulsar doing better, or?
There's a number of articles that have been written up, and actually not by TIBCO. So I definitely point you. I know there's a Medium article out there by a colleague that did some extensive testing that shows, that Pulsar is definitely more stable when it comes to latency. Going into the whole latency high throughput conversation, we can go down a whole path. My whole career has been in messaging at TIBCO, and Rendezvous was built for performance. I mean, it was the Ferrari of its time. And then our TIBCO FTL product is the next generation, I would argue, of that high performance messaging, where we were in that race to zero for latency. Where we were measuring physical operational calls down to the nanosecond. What we've learned from that race to zero, though, is that, you know, the key piece for latency is really the ability to be predictable in latency. You want a solution that has a predictable latency. So it's not just about being fast, it's about being fast consistently. And that's where I think Pulsar has a little bit of advantage over Kafka. Kafka's latencies can be fairly good, but as that system starts to scale, you'll start to see a lot more standard deviation in the latencies that are being represented.
It's not the fastest
Pulsar,
it's not the fastest lap time that counts.
Yep. And throughput's the same thing. It's funny because, yet again, going into those conversations of what is the requirement? You know, how many times do we hear the statement of, I need a high throughput, low latency application? And that's a very valid request. But getting high throughput and getting low latency have two very distinct operational patterns. To get high throughput, I have to batch data. I have to cram as much data into the pipe as possible. By definition, that creates latency on an individual message perspective. I have to do that. So it's all about trade-offs in those scenarios, is what is the goal and what is the priority.
Okay, we're almost at the end. I suggest one last question and then we wrap up. And that's more about, and that we haven't discussed that much. It's more on a cloud. It's more on cloud solutions and how they are data paths rather go Google PubSub or an AWS SQS.
So the cloud solutions are definitely viable options, but I'll give you the anecdote I always like to say is, and this is not a knock on Amazon in any way, but it's a statement of truth on what they're trying to accomplish with the solution. Amazon SQS, Amazon SNS, the very first word that are in those solutions is simple. They are designed to be simple data pipelines. So it's a simple queuing service. And so for simple applications, they work great. If I'm building an Amazon application that's building out a marketplace and I need to connect point A with point B, absolutely perfect for doing that. The question then comes in is what if I need to take that application now and tie it into a back-end solution like SAP? What do I do if I need to tie that into a back-end Kafka infrastructure? That's where those solutions become challenging. Because yeah, I could write my own adapter, I can pull that data in, but now I'm managing all of that because those solutions don't have that foundation of enterprise types of communications. So where I say is those are great starting points. They're great ingest points. But if you're looking to grow large-scale cloud-based applications, that's where you start looking at more proven solutions in that area. Not saying that they're not good for certain applications, but again, it's where is the application going?
Okay, fine. I suggest that we wrap up now. I found it very interesting to also the preparation, by the way, Bill. And again, big thank you for your time and effort to help organize this. Again, to all the participants, I wish you a very pleasant evening. Feel free to reach out to us in case of further questions, assistance, services, products, for good product support on these messaging solutions by TIBCO in collaboration with IHC. And again, I wish you all a very good evening and goodbye. And hopefully we will meet once face to face. Keep safe.
Nice to say. I look forward to the day we can sit down and have a good Belgian beer and
we invite you on site, Bill. You're very welcome. See you all.
Sounds great. Thanks, everybody.
Bye.